This video is brought to you by Academy of Higher Learning. Hello and welcome to today's video. In this video I'll be doing some examples and I'll be finding the derivative of functions using strictly product rule. So basically in today's agenda is just examples. But before I start, here's a recap of the product rule. When we have a function that is a multiple of two functions such as r of x equals p of x, q of x, in order to find the r prime of x, what we have to do is take the derivative of the first function times the second function plus the derivative of the second function times the first function. And if you have three functions, I'm just going to show you that too. So p of x, q of x, and s of x. Basically what we do is the r prime of x would be just same thing again, but taking derivative of one function at a time. So it'll be p prime of x times the second two functions, so q of x, s of x, plus q prime of x times p of x and s of x, plus lastly s prime of x, the last function, times p of x, q of x. So if you haven't watched the video, watch the video where I like go over product rule. This is just examples. So our first example is pretty simple. F of x equals x times x minus 4. Now you can expand this and find the derivative using just the basic rules, but since this video is just product rule, I'll just be using product rule. So I'm going to take the long way and say that p of x equals x, and p prime of x would be 1. Q of x equals x minus 4. Q prime of x would be just 1 again. So just replace the values with p of x and q of x, and then just apply the product rule, which is p prime of x times q of x plus q prime of x times p of x, and just now we just have to sub the values in since we have everything. So p prime of x is 1 times x minus 4 plus q prime of x is 1 again, so plus x. Now you can easily simplify this, so it'll be x minus 4 plus x, and it'll be 2x minus 4. And if you want to take the long way, it'll be pretty much simple here. So it'll be x squared minus 4x, and it'll be 2x. F prime of x will be 2x minus 4. And this is f prime of x, sorry. So that's just the first example. Second example, we have it in rational form, and we have to turn that, like we have to bring x plus 3 up at the top. So just rearrange it by saying f of x equals x minus 3, and bring x plus 3 at the top, and it'll be minus 1 here. And next we just apply the product rule. The derivative of the first function is just 1 times the derivative of just the second function, so it'll be plus the first function, x minus 3, times the derivative of the second function, which is, remember this is this is going to be kind of chain rule, so the minus 1 is going to come at the front. The thing, it's going to decrease by 1 exponent, so it'll be x plus 3 minus 2 times the inside, which will be just 1. And next we can just factor out x plus 3 to the power of minus 2. 3 to the power of minus 2. And that will give us x plus 3 minus x plus 3. I just expanded this and just it'll collect like terms, so it'll be 6 over x plus 3 squared, and that's the derivative. And sorry, I forgot the f prime of x again. Okay, so that's pretty much it. Simple. Next is a word problem. So it'll be determine the value of the dy or dx when x equals 3, and the function is f of x equals x 5x minus 2, 5x plus 2. So you can do this two ways. Again, you can expand it and then take the product rule, or you can take the product rule with three functions. So I'm just going to show you both ways. So first way, I'll just take the product rule of all three functions, and that will give me, so the first is x, so that'll be just 1 times the two functions, x plus 2, plus the second function, the derivative of the second function, times x, the first function, um, times the last function, so fx plus 5x plus 2, and lastly again 5x, but this time it will be 5x minus 2. So that's the derivative, and all we have to do is just sub in f prime at 3, and we should get 671. So this will equal 221 plus that is 255 plus 195, and that will be 671. Now this is kind of a long way. It's better to expand it and then take the derivative of two products. So a short way will be something like this. So I'll just change the color. So if you have f of x, again x, 5x minus 2, 5x plus 2, just expand the x and these two functions. So it'll be 5x squared minus 2x, 5x plus 2, and then just take the product rule of these two functions. So f prime of x would be derivative of the first function, so that'll be 10x minus 2 times 5x plus 2, and the derivative of the second function, so that'll be just 5x squared minus 2x, and that will give you, this part will give you 476 plus 195, and that should equal 671. So that's the answer. The fourth example is you need to kind of think about it. So it'll be show that the line 4x plus 13 equals y is tangent to f of x equals 16 over x squared minus 9. Now, since we have to prove that this line is tangent to this, that means that the derivative of this function should equal 4. So we had to put the derivative of this function to equal to 4 because the derivative is the rate of change, and that is described by the slope of this function. So first we need to take the derivative of the f prime of x, so find f prime of x. Then we need to equate it to 4, and then whatever we get the x value, we just need to sub it back into the original function to find the point. So sub the x value into f of x. So I'm going to just change the color once again. So f prime of x would be equals minus 2 times 16, and this will decrease by 1 power, increase by 1 power, so it will be x cubed, and this is just 0. So next we just equate it to 4, because that's the slope here. So it will be 4 minus 2 times 16 x cubed. Just bring x cubed to the other side, so 4x cubed minus 32 divided by 4, x cubed equals minus 8, x equals minus 2. So there's only one answer to this, and then we just then we just find f at minus 2, and that will be 16 over minus 2 squared minus 9, 16 over 4 minus 9, and that will just give you minus 5. Therefore, its tangent at point minus 2 minus 5. So that's pretty much it to this question, and that would be the answer. So the last question is kind of application, and it's a word problem. So basically it says that a 100-liter tank is leaking. The volume of the tank can be measured by the following function. So V at t equals 100 times 1 minus t over 24 square, and the interval is 0 to 24, so it's in hours. And basically we need to find the rate of change when there is only 70% of tank left. So first we need to find how much is 70%, and that is kind of simple. It's going to be 70 liters. Then we need to find the derivative. No, then we need to find the t value. Find t value at 70%. Then we need to find the derivative of the function, the derivative, and lastly we need to sub the t value in to find the rate of change. Sub t value into v prime of t to find to find the rate of change. So that's what we have to do, and so let's start. Oh, sorry. And so basically we already found 70%, that's 70 liters. Now we just need to find the t-value. So what we have to do is say 70 equals 100, 1 minus t over 24 squared. Now just solve for t by bringing everything to one side. So that'll be root 0.7, 1 minus t over 24. I don't have enough space, so I'll just bring it here. So 0.7 minus 1 times, that'll be over to minus 1 over 2 over 24. And just now just solve for t, that will equal 3.92. I didn't show my work, but I'm pretty sure you guys can do it. You guys understand how to find the t-value. So it should equal 3.92. So next what we have to do is find the derivative of this function. And that's really simple. We have to use the product rule. So the derivative of the first function is 100, so that will equal 0 regardless. Then we have to just take the derivative of the second. So that'll be 100. And we have to apply the chain rule, so times 2, 1 minus t over 24, and decrease it by 1 power, so it'll be to the power of 1, and then take the derivative inside, and that'll be minus 1 over 24. And then we just need to, that'll be prime of t, then we just need to sub the value that we found, 3.92, into the function, and that'll be 100 times 2, 1 minus 3.92 over 24, to the power of 1, minus 1 over 24, and that should equal something like minus 6.97, and remember the units, that is liters per hour. So that's the answer.